the function given by f of x is equal to 3x squared minus 3 cubed, then the average rate of change of the f on the closed interval 1 to 5 is.
So we're looking at a rock, and a rock is basically just a slope equation, y2 minus y1 over x2 minus x1. So in this case, they gave us what our bounds are. So we have f of 5. Let me take this packet out. That's better. Minus f of 1 all over 5 minus 1. So let's do the bottom first, which is 4. For f of 5 and f of 1, let's do the work on the side. I'm going to do it right here. F of 5. And they gave us a function, so let's write in 3 times 5 squared minus 5 cubed. And I think I'm going to do the first part in one go. What is 25 plus 3?
Plus 3?
Not plus, times 3. 75. And we know 5 to the power of 3 is 100 and?
25.
Very good. So we know that first part is 50. And that's our first numerator. Is it negative 50? It is negative 50. Boom, good catch. And then our next one, that's a negative sign, we have f of 1, and 1s are always nice to compute. If I plug in 1 here and 1 here, it's basically 3 minus 1. Is that right? What is 3 minus 1? 2. So when I do further go on, we get negative 52 over 4. And 4 does go into 52 clean, right?
Yeah.
Negative how many? 13.
What's the formula for
F of x2 minus f of x1 over x2 minus x1, which in the end becomes the slope formula. Okay, for number 7, Zach, let's read.
If on the interval or the integral of 4 to negative 10 gx dx equals negative 3 and 4 to 6 g of x d of x equals 5, then negative 10 6 g of x dx equals.
So let's go ahead and write in integral from negative 10 to 6 of gx dx. So we have to kind of integrate this by parts because not everything is given to us. So I have to start from the bottom to top. So the lowest point is negative 10, and I'm going to go up to 4 for the reason of this right here, because I can borrow that, of g of x dx. And then I will go from 4 to my very last, which is our 6, g of x dx. So then let's kind of discuss what's happening here. If from 4 to negative 10 is negative 3, and I swap them, I told you guys when we were looking at the integrals, when I swap them, what happens to the sign? It changes, so that becomes positive 3 in the end. And then the next one is pretty clear. It is as it is. We have plus 5. So 3 plus 5 is how many? 8, which is answer choice D. Let's go on to number 8.
How did we get negative?
If from 4 to negative 10 is negative 3, then negative 10 to 4 is positive 3. It's always the opposite.
Will it always be positive?
No. So if the original was positive, the new one will be negative. So good. It's basically the opposite. Okay? Number 8 is something that you might need a little pre-cal reminder. Okay, Danielle, let's read number 8.
If f is the function given by f of x equals e to the power of x over 3, which of the following is an equation of the line tangent to the graph of f at the point 3 natural log of 4, 4?
So for the tangent, I need a point and I need a slope. Is the point given already?
Yes.
So we already have our x1 and y1. So just to match, let's see if the x's are together and y's are together. Look at D. Should it be y minus x1? It's y minus y1, right? So we can automatically eliminate that. So all we have to do is find the slope. So let's, I was going to say integrate. Let's find the derivative. Let's do a reminder of e to the x. It is itself times the derivative of the what? Of the power. What's the derivative of 1/3 x? 1/3. And then I need to put in this ugly x value, which in the end becomes kind of clean. So we have f prime of 3 natural log of 4, meaning I'm going to plug that into this tiny little x, e to the power of 3 natural log of 4 over 3, and then times 1/3. What do we notice about the exponential or exponent that I can eliminate? I can get rid of that. So when I do, I get e to the power of natural log of 4. And I'm just going to put over 3. That's considered 1/3. So we have an understood base of every natural log of e. And as long as I have a natural log and we have a component that's repeated, I can get rid of it. And our final answer is 4/3. Do I need to show you why it's gone using pre-cal concept? Or are we okay with this? Okay, so our 4/3, the only one that's got 4/3 is answer choice what? A, very good. Now let's go on to number 9. Number 9 seems abstract, but it's really not. So Addison, let's read number 9, please.
The graph of a function is shown above. The following expresses the relationship between 0 to 2 x dx, 0 to 3 f of x dx, and 2 to 3 f of x.
So then let's analyze the graph before we even look at the answer choice. If I have everything above the x-axis, it is positive, and everything below is what? So we have positive and negative. So let's analyze what's happening. From 0 to 2, it is positive, right? So I'm going to put a plus sign. And I'm going to make a big plus sign for a reason because I'm thinking ahead. And then I want to look at the last one. From 2 to 3, it is negative. And now I'm putting them together. From 0 to 3, if I have big positive minus little negative, what do I actually get? Bigger positive or just a little bit positive? A little bit positive. And then if I were to compare that, and that should match one of the choices. And I want you to analyze that real quick and see which one should match the bigger positive, the little positive, and negative. What answer choice? D it is. All right, our last one, number 10. For this one, I'm not going to have anybody read. Basically, we have to use U substitution because I want you guys to analyze the inside. If I derive the inside, do I get something x squared? Yep, so we know that is our U. So let's write in. U is equal to, we have x cubed plus 1. So du is equal to, we get 3x squared dx. And when I compare, I like the x squared and dx, but I do not like which part? The 3. So I'm going to kick it off to the side. 1/3 du is equal to x squared dx. And then let's directly substitute. So I see the integral. I'm going to go ahead and change my bounds. So we have the original says x equals 2, x equals 0, and I want to plug it in here. And I'm going to reason why at the very end, because you'll be able to see a better picture. So if I do 2 cubed plus 1, how many is it? 9. And then if I take 0 plus 1, that's going to give us 1. So I'm going to kick out the 1/3. We have 1 to 9. Then we have u to the power of 1/2. And let's do the add 1 and subtract 1. So if I add 1 more to the u, what do I get? U to the power of 3 over 2. And when I divide it by it, I'm going to go ahead and do the reciprocal. Are we okay if I just go ahead and put 2/3 right here? Because I'm doing multiply by the reciprocal by hand. And then we're computing from 1 to 9. But I want to simplify even further. We have 2 over 9, u to the 3/2 from 1 to 9. Now let's discuss what's happening. If I take u to the power of some ugly fraction, do you really want to put x cubed plus 1 back in there? Very ugly, right? But if I just give you a single number, I can square root it and cube it, okay? So let's go ahead and write out what we're plugging in. The first one is 9. So we have 2 over 9 times 9 to the power of 3/2 minus 2 over 9 times 1 to the power of 3/2. We know this part's not a problem. It's just 2 over 9. So we're going to do the remaining mentally. So eyes on the board. What is 9? 9 square rooted.
What?
When I square root the 9, what do I get?
3.
3. If I take 3 cubed, what do I get?
9.
27. Okay, that was just this piece over here. And then think of 27 in your head, divided by 9. 3. 3 times 2. And that will be our value. If you want to write it all out, go for it. But if you're okay at organizing it, that's okay too. And then I want to do common denominator. Our common denominator is 9. How can I represent 6? By saying something divided by 9.
6 times 9.
That would be 54. And when I do 54 minus 2, I get 52 over 9. And it looks like we have a